Hello everyone, my name is Janvi Mehta. Today, me and my teammate Varun Bhosle are going to present our IoT project based on home automation system. We are the students of Dwarkadas J. Sangvi College of Engineering in Mumbai. What are we going to look at in this presentation? We are going to learn about EMERTXE, the company that offered us this internship, what we have learned during this internship, the introduction to IoT, embedded systems, features of the system that is our project, requirements, the tools used, the screenshots and demo of our project, and the conclusion. EMERTXE. EMERTXE is India's pioneer institute for embedded systems courses, Linux, and IoT training, and it is situated in Bangalore. It has exhaustive courses for embedded systems and IoT technology. Let us look at what we have learned during our internship. We got to know about the introduction to IoT, the basics of C and C++ programming, about IoT and embedded systems, programming in Arduino, IoT devices and their working. So why C? C is a robust language and it has many built-in functions and operations which can be used to write any complex program. C is generally considered the key programming language for embedded IoT devices, and it is well known for its portability and microcontrollers programming for IoT devices for computing. Uh, so, uh, the concepts in C were started from the very basics. We learned about the data types, the conditional structures, the if else statements, the loops like for loop and while loop, the functions about recursion. Then we learned how to code arrays, string, pointer, and user defined data types, the macros, and the object oriented programming about that. Firstly, for C++, we came to know about the difference between C and C++, about what is object-oriented programming, what are access specifiers and modifiers, constructors and destructors, what is abstraction, inheritance, exception handling, and polymorphism. Introduction to IoT. What is IoT? IoT is the network of physical objects that contain embedded technology to communicate and interact with the internal states or the external environment. It is merging perspectives between the devices, systems, and humans to build a better understanding of the world around us. This is the IoT architecture. The components used are the IoT devices on the client side for device connectivity and cloud. And we use the IoT backend for data processing and analytics. And then we use the presentation connectivity. What are embedded systems? An embedded system can be thought of as a computer hardware system having software embedded in it. An embedded system is a microcontroller or a microprocessor based system which is designed to perform a specific task. For example, a fire alarm is an embedded system. It will sense only smoke. Some real life applications of IoT and embedded system are the Amazon Echo Voice Controller, the smartwatches, and the smart lock system. Features of our project. We have the garden lights control. Lesser the sunlight is available, the brighter the garden lights will get. temperature control system. In this, switch the heater and cooler on and off. Switch the heater off automatically if temperature indoors exceeds 35 degrees Celsius. Water tank inlet and outlet valve control. Switch inlet and outlet valve on and off remotely. Switch inlet valve off automatically if the tank fills up, and turn inlet on automatically if volume of tank drops below 2000 liters. So let us look at the block diagram. So we use the Pixum Lab simulator, and the we connect it to the Blynk IoT mobile application uh, uh, to control the home automation system. In the Blynk IoT app, we have made switches to control the cooler button, the heater button, the water volume. To We have a terminal for notifications on what is happening. We have inlet valve, outlet valve, and temperature sensor reading. In Arduino Uno board, we have connected the LED, the LDR, the Ethernet shield, the temperature system, the LCD, and the serial tank. Let us look at the tools used. The garden lights, they use the LDR sensor and LEDs. The temperature system is LM35 sensor. The microcontroller used is the Atmega 328 on Arduino Uno board. The for internet connectivity, we are using the Ethernet Shield. For development tool, we are using Arduino IDE. For simulation tool, we are using Pixum Lab. And for IoT mobile application, we are using the Blynk app. And for serial communication, we are using the Null modem emulator. So the tools used, let us look at them individually. Arduino Uno. So it is based on the Atmega 328 microcontroller chip. The Arduino Uno includes 6 analog pin inputs, 14 digital pins, a USB connector, a power jack, and an ICSP header. So, the Pixum Lab simulator. The Pixum Lab supports several devices that can be connected to the boards for simulation. They are also called as the spare parts. For example, LEDs and push buttons are used for simple outputs and inputs, and some more complex ones like the Ethernet shield for internet connection or the color graphic display with touchscreen. The Blink IoT app. It is used to connect the microcontroller through the cloud. We control the heater and cooler buttons through the app, and also the inlet and outlet valve for the serial tank. It shows us the readings of the temperature, the volume of water in tank, and the notifications.
LDR sensor. LDR sensor is a light detecting sensor that detects the light that falls upon it. The photoresistor is a light controlled variable resistor. The resistance of a photoresistor decreases with increasing incident light intensity. The LED lights are connected to the LDR via the ADC. The ADC converts the analog input by the LDR into its equivalent digital form, which is then converted by a certain formula from 0 to 255 as the upper bound. Based on that, we glow the LED. The properties of the LDR sensor is applied to accomplish the controlling of the garden lights. During the day, the outdoor light is maximum. So, the LDR sensor detects the light and the garden lights are turned off. Whereas, at night, the outdoor light is very low. So, the LDR sensor detects it and the garden lights are turned on. Next we have is the temperature system. The temperature control system consists of a heating resistor, a cooler, and an LM35 temperature sensor. The analog value of temperature is obtained from the temperature sensor LM35 and it is displayed on the LCD after converting it into a digital value using the ADC. We can control the temperature of the system by turning on or off the heater and cooler button through the Blynk IoT mobile app. Then we have the Ethernet W5500. This chip is a hardwired TCP/IP embedded Ethernet controller that provides easier internet connection to the embedded systems. Using this Ethernet shield, the Arduino Uno is connected to the internet. Then comes the serial water tank. It reads the volume of the water in the tank through serial communication and displays it on the CLCD. Controls the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication and display the volume of water in the tank on the CLCD as well as on the Blynk IoT app. Here are the screenshots of the code that we have implemented and the screenshot of the model. Now we'll give you an actual demo. So here is the Pixim lab. We have already dumped the code into it. Here is the spare parts, the actual model of our project. Here is the serial remote tank. Now I'll mirror my phone to show you the Blynk IoT app. Okay, so here we can see the home automation system. So we have used the widgets to create buttons for cooler and heater. There is a gauge to measure the temperature. There is a notification bar wherein we can see the notifications. There is a separate tab for controlling the water volume. Even here we have used widgets for the inlet valve and outlet valve buttons and also a gauge to measure the water volume. So once we turn the heater on, even the CLCD shows that the heater is turned on and the temperature starts rising. Once we turn it off, the temperature starts falling, and if we turn on the cooler, the fan rotates and the temperature comes down quickly. Okay, now if the temperature of the room exceeds 35 degrees Celsius, the heater will turn off automatically. See, we got a notification here that the temperature is above 35 degrees Celsius, so turning off the heater, and the temperature starts falling. Now talking about the serial water tank. Okay, so once we click on the outlet valve, the water starts moving out. Once the water level falls below 2000 liters, the inlet valve will be turned on automatically to ensure there is enough water available. And once the tanks get filled, the inlet valve stops automatically, so there is no wastage of water. We also got a notification here that the water level is full, so turning off the inlet valve. Now talking about the LCD, when it's when there is no light available outside, the more resistance, so there will be the LED will glow fully. If there is bright outside, so the LED will be turned off. Moving back to our presentation. Okay, So, what have we concluded from this? We learned the basics of IoT using Arduino IDE, Pixim Lab, and Blynk IoT app. We were able to make a home automation system and complete all the requirements given. We were able to vary the garden lights according to the brightness of the sun, able to use the temperature system, and able to control the cereal tank. The CLCD acted like a dashboard for displaying the events. Widgets from Blynk app, like buttons, were used to control heater, cooler, inlet valve, and outlet valve. Gauge widgets were used to display the temperature and volume of water. The terminal widget was used to show the notification. After this project was completed, we the EMERTXE Infotech organized a Disha workshop for career guidance of the students, how to build a resume, preparing of interviews, and some do's and don'ts regarding future. We would like to thank EMERTXE Information Technologies for giving us this opportunity to be a part of their internship program. We would also like to thank all the mentors who taught us, guided us, and made this project a success. Thank you.